Hey everyone and welcome to Java tutorial for beginners, the only resource you need to learn Java from scratch with no programming experience required. This tutorial has 5 parts that you can find in the Java programming playlist, and in this 4th video we're going to learn about classes and objects, static modifiers, and we're going to also scratch the surface on the object-oriented principles by learning about inheritance. So without further ado, make sure to hit the like button and let's jump into it. Alright, so in this lecture, we're going to talk about a concept of a class in Java. We already introduced that concept in the lecture where we talked about the structure of a Java program. But now we're going to make a really important deep dive into this concept that we're going to really understand its importance and how can it really be used in day-to-day applications. So basically a class has this very simple syntax where we have to specify an access modifier which can be public, private, protected, and also default. So if we're not adding here any access modifier, then it is considered to be the default one that's being enforced. But let's say we have this public modifier. As I mentioned in the initial lecture when we talked about the structure of a Java program, the role of this access modifier is to restrict or allow the communication between different classes to take place or not. And we're going to also have an example on this further in this lecture. After this access modifier, we have to add the class keyword, which defines the fact that we want to declare a class. And then we need to add a class name. And this can be basically any name that you want, any string that you want. Of course, it has to make some sense in the context of the application that you're currently using or building this class. And then we open braces, and then inside those braces, we have the definition of the class. Any Java application needs to have one class that contains this important method, which is basically the main method, the one where your application starts to run, starts the execution. And we're going to see that when we run this program or any Java application from command line or from a different, let's say, environment other than IntelliJ IDEA, you are required to specify the main class name, which includes the package, where the runtime will find this main method. So now to get a better view on what a class actually is, the definition of a class is that a class is basically a template based on which we can create objects. And this is not really useful actually if we just take it in the way it is, because it doesn't really tell us any useful detail on what the classes can actually be. So the best way to explain what a class is by just taking an example and working up from there. So in a Java file that we have here, main.java, we can basically create any number of classes that we want. So the only restriction is that we need to have a single public class inside this file. If we're trying to define 2 public classes, it will tell us that it needs to have a dedicated file. So for that reason, we're going to make it non-public. So the default access modifier will take place here. And of course, we're going to remove this method as well. Because as I mentioned, any Java program needs to have exactly one main method. So first of all, let's add to this class a name that we're going to modify in a second. We're going to call it placeholder for a minute. And now I want to express basically the 2 main components that a class can have. So on a class, you can define variables or fields, right, which are basically simple variables. And we're going to see that they can also have access modifier attached to them. And apart from the variables that we can declare on a class level, we can also declare methods or functions. So those are the 2 main entities that a class can contain. So to get a better idea on how this actually works or how the structure of a class may look like, let's imagine that we want to build an application that is basically a primitive version of the Need for Speed, where we have a car and we can control it using different inputs, right? Different keys. And the car has different behaviors depending on how the user is actually working or playing the game. So for that reason, we're going to create a class that we're going to call very simply car. And this class basically emulates the state of a car at any given moment in time, because the game, as you can imagine, has a continuous track, right? So depending on what the user is doing, the car modifies or updates its parameters. So first of all, let's talk about the structural properties of a car. And we can say, for example, that we have a variable that stores the number of doors a car can have. It's not really useful for that particular game, but for the sake of example, we're going to also create a variable like that. So we're going to store the number of doors, let's say doors count, in this variable, right? The other property that a car can have is, for example, the fuel level, right? So let's say a fuel level of 0 means that the car is out of gas, and the fuel level of 100 or 10 means that the car is basically full of gas. Okay. Let's say, for example, the speed might be another property that we can store around the car, right? Depending on what speed it does, the fuel level updates accordingly. So this is a functionality that we can implement inside this car. So let's also add some comments here. Let's say if fuel level is 0, the car is out of gas. Actually, let's add here an interval. Let's say 0 to 100, right? And also here, let's say 0 to 100 kilometers per hour, right? To any speed, right? Kilometers per hour. So this is basically an integer value, but we're going to interpret it in this way. So basically what happens here is that we just declared a couple of fields on that particular car. This is just the definition of a class, right? So if we run the program now, basically nothing happens because this car is not being used. As you can see here, IntelliJ IDEA is telling us that the car is not even used, so it doesn't basically do anything. Now that we created this class with those properties, let's also add some methods on that class that allow us to do some certain functionality. For example, we may have a method that increases the speed of the car by a specific amount. Let's say increase speed, and we can pass here the amount as a parameter. So what will happen is that in this method, the implementation will be the following. So we update the speed variable by the amount that was specified, right? So the speed will increase. We can have a similar method for decreasing the speed. And in this case, the speed will decrease by the amount that we specify, right? We can have another method that tells us to fill the tank of the car. Fill the tank. This method doesn't take any parameter. Of course, if you want to fill the tank by a specific amount, you can take the amount as a parameter as well. But in this case, we're just going to say fuel level equals to 100, right? We just want to fill the tank and that's it. And of course, the fuel level initially should be 0, for example. So this is the definition of a class. Now let's actually use it to kind of get some idea. But before using it, let's also add a really nice property that will be actually a string. And this property will be the name of the car. We're going to have in this name the make or model or any combination of that. I'm just going to say this very simple, the name, right? To be more easy to work with it. So this is how the class definition looks like, but now let's use it. So the main method, we're going to create an object of this class. And the syntax is the following. Car BMW equals to new car. This line basically tells us that we want to create an object of this car class, and the object is named BMW. Or in other words, the reference of that particular object is named BMW, or also the instance of the class is called BMW. So there are a number of names around this, but the idea is the same. So right, so the object is called BMW in this case. So what this actually does is to create an instance. So it will allocate memory for that particular object. Now you can see that this is very similar to defining a string, for example, right? For example, if we have something like this, right? This is very, very similar. We are using the new keyword, which is telling us that we want to allocate memory for this new instance, and we're also specifying the name of the class as well. Of course, in the case of string, we can basically simplify this in this way, because the string class is, of course, defined in the standard Java library. But I wanted to bring this up because any class that we create can be seen as a new type, as a new data type that we create in Java, right? That's a really important thing that we should keep in mind. All right, so now going back to this very simple object that we just created, right now it's basically empty. So it doesn't have any properties set up on it. So the speed will be 0. The doors count variable is not initialized. The name is not initialized, right? So we can't really do anything with it at this moment. We have to use this object to add some data on it, right? So let's do that. So in order to access some variables on this particular class, we have to use the instance name, and we need to use the dot operator. And as you can see here in this drop down, we can see different fields that we have defined on that class. I'm going to use all of them. Let's say the name is BMW, the doors count is 5. The fuel level is 0, but we also want to initialize the speed to 0 as well, okay? So this is the way you set some data on those fields, okay? Now let's say we want to increase the speed of this car. So to be able to do this, we have to say BMW dot increase speed, right? Which is the name of the method that we just defined on that class, right? And here we need to add an amount. Let's say 20 kilometers per hour. So after this method call, the speed of the car will be increased to 20 kilometers per hour. We can also print this as well. Let's see, the speed of the car is bmw.speed, right? To access the speed variable. And if we run this, we should see the speed of the car being 20 kilometers per hour. Of course, if we increase the speed by even more, right? Let's say we increase it twice by 20, we should see the final speed as being, of course, 60, right? The first print is 20, the second print is 60 kilometers per hour. So what this means is that on the instance level, this actually acts as a dedicated variable. So any update on this particular, on the state of the object will basically be held or reflected on it as well, okay? That's a very important thing to note. So now if you take a look on the way the variables or the methods behave with respect to a class, or specifically to what they actually mean inside a class, we notice that the variables or the fields, they represent the state of the object, which is the persistent value or the state of the object, right? And the methods or the functions represent the actions that can be taken, that can be applied to that state, right? So the way we can modify or update this internal state. So this is the way we should perceive the fields and the methods of a class. Now, a really important thing is that on the variables that we have on a class level, we can attach access modifiers. In the same way we attach them to a class like public, private, and so on, we can also add them to the fields as well. So in this particular case, we can say something like this: private string name, right? And we can attach this to pretty much any field. And of course, this is technically a best practice, because if you take a look on the way the class actually works, in this code here, previously we were modifying the name of the class from outside of this object, right? So from this particular code. And this is usually not desired, because if you have a class that has some internal state, it should manage that state internally, by simply having a custom logic inside that takes care of that class. You don't want other code to be able to modify your variables inside a class. So as you can see, immediately as we mark them as private, they are now not accessible from the outside of the class, because what the private modifier means is that you can only update this field from inside your class, like we do right here, right? We are updating the value of speed, and speed is an internal or private variable on this particular class. So you may wonder, how can we initialize those fields if they are private, right? Because in this case, we can't set the name of the car if this variable is private. Well, for that reason, we have a dedicated function or method that we can create on a class, which is called a constructor. And it has this unique syntax. So we have to say public, followed by the class name, and then followed by any number of parameters that you want. So the role of this method is to take some initial data from the outside of the class, and inside it you can add some initialization steps that you can apply on the new objects that you want to create for that class. This is a very important connection between the concept of a class and an object, because the constructor is only called automatically when you create a new object of this class. So in other words, when we make this call, it will jump directly on this constructor. Okay, that's how it works. So now let's use IntelliJ IDEA to automatically generate a constructor for us using all those private fields as parameters, because we want to initialize this class with all those two fields. So for that reason, we're going to tap double shift left, and we're going to search for constructor. And if we hit enter, it opens up this really important dialog where we can select which fields we want to be parameters in this constructor. And we want to select all of them, right? If we hit enter, we can see the constructor being auto-generated by IntelliJ IDEA, which is a really great thing. So we can see here in the parameters list all the fields which correspond to those private ones that we have defined in the class. And for each of them, we have this assignment operation, which is telling us that we want to grab the value of this parameter, which is basically received from the external code, from the code that calls this constructor. And that value is basically assigned to this particular internal variable. In this particular case, the this keyword refers to the current object that we are trying to create. So for example, if we take a look here, when we create this particular object here using this syntax, the this keyword actually refers to the object that will be created, or in other words, to the BMW object. Okay, so in this constructor, when we are saying this.speed, we're basically storing into the speed variable, which belongs to the BMW object, the value that we just received here as a parameter. So if we have to print the value of speed right after we create the object, we're going to see it updated accordingly. And we're going to see that in just 1 second. So that's pretty much all about the constructor. Now let's use this constructor to see how it works. So now you can see we have an error here because we need to provide 4 arguments for this constructor, and we haven't provided anything. And we have to fill those out. So first of all, we need to add the name here. And then we need to add the doors count. And then we need to add a fuel level. Let's say 10. And then the speed. And the speed, let's say, is 24. Of course, we need to remove those ones. And now we can, of course, call methods on that object as we saw previously. We cannot access the speed variable because it is actually private. And with private fields, if you want to access their value, you need to add a method which is called a getter. And that method has the following syntax. It should return the type of the field that we want to return. It should have a name. This is not necessarily required, but it's best practice to have a name that starts with get, followed by the field name. And then here in the body, we just have to return the variable speed. So if we go back to the main method, so here we just have to say bmw.getSpeed, right? So instead of a field reference, we have to make a method call. So initially, I want to print the existing speed. That should be 24 because that's how we initialized the object. And then we should see 44, right? And then 84 because we increased the speed by 20 twice. So let's run this to see if this really works as we expect. Yeah. So as you can see, we got initially 24 because that's the speed that we just provided in the constructor. And then we have 44 and then 84, right? Based on the way we increased the speeds using this method. So the constructor is a very important concept that we need to know about. And also, pretty much all the fields that we have on a class should be private. And this is a best practice that we should definitely follow in any class that we create. And at the beginning, it should really feel a little bit awkward because you can simply access the field directly and not have to care about the access modifiers or anything like that. But on the long run, this will not lead to a really good behavior that we should have, because this is a very important principle in object-oriented programming, which is called encapsulation, and we're going to tackle that in a future video. So I want to also cover two aspects that we need to really take care about. And the first one is related to the access modifiers that we should add on the methods. So in this case, we don't have any access modifier here on those methods because they are using the default one, but we can also add here the private modifier as well. And if we do this, we can see that we cannot access or call this method anymore here because it's private now. Usually, private methods are only used when you want to call them from other methods that you have inside your class. And that's the only way where you should use the private modifier on the method level, right? Because usually any class should have kind of a public method to be able to interact with the external code. All right, so now we're going to touch a little bit more on the observation that we made in the previous lecture, where we saw that a class that we declare acts like a new type that we add in our application, right? If we look at it from the declaration point of view, or from the way we generate objects using that particular class. So we're going to take a look on a very simple example to really understand the difference between these new types that we just create using classes and the traditional types that we just talked in a previous lecture. So let's create two car objects. The first one is the BMW and the second one will be the Mercedes, let's say. I'm just going to update the name of the car, but also the doors count. Let's say this one has 3 doors. This one has half the tank and the speed is 50. So let's print first the speed of both objects. So bmw.getSpeed, same thing for Mercedes. And let's say we want to update the speed of the BMW by increasing it with 30 kilometers per hour. And then we print both of them again to see how this actually works. So most probably in the way we would expect. So the initial speed of the BMW is 24, as we have here in the constructor. The speed of the Mercedes is 50. And because we increased the speed of the BMW by 30, we got on the second print the value 54. And for the Mercedes, this value remains unchanged, right? But now let's see what happens if we change this particular object creation here to something like that. So we're basically assigning to the Mercedes object the BMW object, right? So we make this assignment on those two objects. If we run the program again, we're going to see something that might be suspect at the first glance. So initially both speeds are the same, but then we can see that the speed of the Mercedes has been updated, although we just updated the speed of the BMW by using this method call here. So basically it looks like the state of the Mercedes object is affected if we make an update to this source object, to the BMW object that we added into this assignment. So in other words, if we make this assignment between objects, it looks like they remain linked right after that assignment has been executed. And this is a little bit different if we consider, let's say, the primitive data types. Let's say we have two variables. We make the assignment y equals x, and then let's say we print all of them. But before printing them, we're going to add 10 to the x variable. So it's basically the same scenario as we have above. The only difference is that we're working with primitive types, so with classical integers. So if we run this again with this new addition, what we can see is that the value of x has become 20 because we updated it here. Initially it's 10, and then we also added 10 on top of it. But the value of I remains unchanged because in this particular assignment here, it just just took the value 10. And then this operation here did not affect the value of y. And let's switch back to the keynote to really understand why we have this difference between primitive types and also reference types. Because there's a clear difference in the way they behave when we get assignments or copying the value from one object to the other. So in the case of reference types, the way they work is in the following way. So we have the BMW object, which doesn't really contain, in the traditional way of thinking, the real value of the object. It actually stores an address, a memory address actually, to a location in memory where that particular content of the car object is being located. So this particular address is basically a hexadecimal number just for exemplification, and it points somewhere in the memory where that content can actually be located. Now, when we make this assignment, right, so the Mercedes object equals to BMW, what happens is that the Mercedes object points to the same address in memory, right, which actually refers to the same content that the BMW object stores. So that's the main reason that when we update the value of the initial object, so the value of the BMW, this change is also reflected to the Mercedes object, right? Because they actually point to the same memory location, right? That's the main idea of reference types, because what this means is that we're defining a type which doesn't store a value. It stores a reference to a location in memory where that value is located. Now, this is contrary to the value types or primitive types, where the behavior is completely different. So when we make this assignment, y equals x, what happens is that the actual value is being copied from the x variable to the y variable. So that's the main reason that further updates on the source variable, on the x, will not affect the y variable, because the assignment operation has been done by copying the values and not managing with references, right? So value types are basically primitive types, so integer, long, and all the other ones that we discussed in the dedicated lecture. And reference types are the ones which are modeled by classes. So this is a really important aspect that we should keep in mind when talking about reference types and also value types. Alright, so in this lecture we're going to talk about the static keyword that we actually saw in a previous lecture, but right now we're going to make a really important deep dive into this particular keyword. So first of all, let's declare a class that we're going to play around to kind of get the idea of this particular keyword. So in any class that we create, we basically have, let's say, a private field, which is, let's say, is internal string, for example. Let's call this field. Actually, should be, of course, string. And let's say we have a constructor, which basically allow us to initialize this field. And we also have a getter method for that field, right? So basically, when we try to create an object of this particular class, we just have to say in the main method, the name of the class followed by the object name, let's say object1, followed by the new keyword, and then a call to the actual constructor of that class. And here we can provide basically any value that we want for this internal field. So what happens here is that when we make this call to the constructor, this value that we pass here on this parameter will get dispatched here, and it will be stored into this internal string field. This particular field is tied to the instance that we're trying to create. As I previously mentioned in the lecture where we introduced the concept of a class, this keyword that we need to add here basically refers to the object that we are trying to create, right? So we can say that this particular field is an object level variable, right? Now, one important thing to note is that we only need to add this keyword right here only when the name of the variable that we're trying to initialize is the same with the name of the parameter where we're trying to get the value from. If this variable has a different name, then we are not required to add this keyword because it only knows by the name reference that we're talking about two different instances, right? That's just a parenthesis to kind of get a little bit the idea on where we are required to use this keyword. Now, going back to our example, if we make a different object where we pass a different value here, of course, this new value will be stored in the internal field variable, which is now related to the object 2, right? So those two objects will have two different fields, internal fields, right? Which are stored in this variable. And if you print them, they will definitely be different, right? So, for example, if we try to print, let's say, object1 field, we can say object1 dot get field. Same thing for object2. And of course, we need to concatenate those two string fields and not pass them as arguments to the printline function. Now, if we run the code, we should see obviously that we got two different variables printed out, right? Because we have two different objects, they have two different internal states basically. So in other words, any fields that we create on a class are instance level fields or are related to the object that is going to be created, which belongs to that class. Now, the static keyword is basically a way to say that we don't want to tie this variable or this method to the instance of the class or to the object of the class. We want to tie it directly to the class. And basically what this means is that we can attach the static keyword to any field. Let's say static field here, which is again a string. And this field right here is not related to the instance of the class, right? It is related directly to the class. And the way we work with it is by using the class name, in this case test, followed by the field name. In this case, the field is private, so we cannot access it. currently, but if we remove that, we can see that we don't have this error anymore. So we can basically initialize it in the same way as we do with any other variable, except that it is referenced using the class name. That's basically the scope where the static fields actually exist. Now, of course, the access modifiers work in the same way with static fields. So if we make this private, we cannot access it from the outside of the class. We can only access it from the inside of the class. And here we can also have static methods, as I previously mentioned, which of course are annotated with the same keyword as well. The idea with static methods is that they can only work with static variables or with static fields. So as you can see here, IntelliJ IDEA tells us that the field cannot be referenced from a static context. So the method is a static context and the field is non-static, right? So it is instance level field. So for that reason, we cannot access it. So we should use basically static fields when playing with static methods. Now, of course, the error is that the method name is the same. So we can just update it accordingly, and we're going to be able to access this method. Of course, any static method should be accessed with the class name. Now we can also understand why the main method of a class is a static method. And the reason is that when the Java application is started, the runtime makes a call similar to this one, main.main. And it passes here an array of strings, which is the program arguments. So the program basically is started from a static context, because when you're launching the application, you don't have or you don't really want to have any instance level context. So you want to start it kind of from an independent execution point, if you want. That's basically the reason that the main method is static, because we don't have to tie it to any context. Now, the last thing that I want to show you around this static keyword is that we also have the concept of a static initializer block. And this is basically just a way to initialize the static fields in the context of a class. And we define a static initializer block in this way. So we just say static followed by brackets directly. And here in this scope, we can play only with static fields. We can basically initialize them. That's the reason the static initializer blocks have been created, because you might want to define initialization logic for those fields as well. Now you can also do this in the constructor, but this approach would potentially create a consistency problem, because the static fields should not be related by design to any instance of that class. And if you are modifying them on the constructor, whenever you create an instance, you also update the static field, right? So you create this connection, which by design should not be there. Okay, so that's usually not a best practice to initialize static fields in the constructor of the class. Now let's use some breakpoints to really understand when static initializer blocks are invoked. So I'm going to place some breakpoints here to kind of see when the program basically goes into the static initializer block. You should basically go a single time. So right now we're basically creating a new instance of the test class. We can see that first the static initializer block is invoked, and then the constructor, right? Now we're back in the main method, and if we continue the execution, we can see that it directly went into the constructor. It doesn't go into the static initializer block anymore, because it is basically run only once. When the first object of that class is created, the static initializer block is executed as well. So because it is a class level construction, it's not tied to any instance, it is only executed once. So one use case where you may want to use static entities in a day-to-day job, let's say, is when you have kind of an utility class, which is something that usually occurs in pretty much any software application. So you can have a class which looks like that. For example, utils is a common name for that. And you can have here a method which, let's say, converts a date from a string to a date object, something like that. And of course, you can have any conversion logic here. So when you have operations that can be done in a common way without relying on any context, as you can see here, we just want to convert the date from one format to the other. It doesn't have any kind of context around it, so you can basically call it from any point on in your application. It's more handy to kind of have something like this, right? Utils.convertDate. So to use this static method directly, instead of creating an object of the utils class and passing it around. Of course, there may be situations where this is, again, not the best practice, but that's like one example that you can use to make an idea when static entities can be used. Pretty much the rule of thumb is that you can use them whenever you get a logical context that doesn't depend on the instance in any way. So operations which can be completely individual or out of context for any instance can be used and modeled using static entities. So with that, let's jump into the next lecture. Alright, so in this lecture we're going to talk about a really important concept that we have in the object-oriented programming, which is called inheritance. So inheritance is basically a way to model relationships between different classes in pretty much the same way they are in the real world. So for example, if you have a class that is called animal, this is a very classical example, by the way, and this class has some kind of functionality which relates generically to an animal. Let's say it has a very simple method that is called walk, right? And here we're just going to print like something like the animal walks. And now let's say we have a different class which is called dog, and on this class we have a different method which is called bark, right? Because the dog barks. Of course, a dog is an animal, right? And in Java we have a way to express this relationship between those two classes in the following way. So we have to say extends, which is a reserved keyword, followed by the class that we want to extend. So as you can see now, this particular name of the class has been highlighted because IntelliJ IDEA is telling us that it recognized the relationship between those classes. So what this line tells us is that the dog class extends the functionality of the animal class. And we refer to the dog class as being the child class or the derived class, and the animal class is the base class or the parent class if you want, right? You can see them in different names in the industry. So basically, the dog class has more functionality, right, than the animal class. So in other words, if we have a dog object, we can basically call the walk method from the animal class. And let's see this in action, right? So we have a dog object, and on the dog object we can call bark, right? Because that's the method defined on the dog class. But we can also call walk, right? Which is a method defined on the parent class, on the animal class. And of course, if we have an animal class, we cannot call the bark method because this belongs to the dog class as well, right? So this hierarchy works from the bottom up, right, if you want. So what happens if we have fields, right? If we have a field on the animal class, let's say we have a simply integer called the number of legs, right? Because any animal has a specific number of legs. On the dog class, we can basically access this particular variable on the animal class. And we can test this out even in this particular bark method, right? If we just search for the variable name, we can see it. But let's say we want to initialize this number of legs variable from the constructor of the dog class, right? So let's say we have the constructor of the dog class, and here we just have to say number of legs equals 4. Now, of course, we are able to initialize and access this variable because its access modifier is the default one, right? We don't have anything specified here, so the access modifier is the default one. So this variable has package level access. Now, if we add the private modifier here, we can see that we cannot access anymore this variable from the child class. And this is, of course, because the private fields are accessible only from the class which defined them. This is a very important thing to note. Of course, this applies to methods as well, right? If we add here the private modifier to the method, we cannot access this method from the child class. Now, instead of the private modifier, we can also say protected. And this access modifier is specifically designed for fields or methods which can be accessed from the derived classes. That's actually its main purpose. So if we have protected fields or methods, we can play with them from the derived classes as well. Now, another really important thing that we should note is what happens if we have the exact same method on the dog class, right? So let's say, for instance, the dog class simply has a different method, right? You can see this in a more generic way, right? You can imagine two different classes connected to this inheritance relationship, and they simply have, for some reason, the same method. As you can see here on the left-hand side, we got this sign, which has a little O on it and an arrow pointing upwards. If we click on it, we can see that it basically directs us to the base class method. So if we hover on it, we can see what it actually means. So it says that this method overrides the method on the animal class. So what this means is that on the base class, we have a method, and on the derived class, we have the exact same method. So when we call this method from the derived class, this particular functionality will be executed and not the one in the base class. It's kind of a specialization of the method, right? That's basically the meaning of the override effect. And if we go on the main method and we click on this walk method, and if we go on the main method and we click on this walk method, we can see that IntelliJ IDEA directs us to the code from the dog class and not on the method in the base class, right? Because it immediately detects that there is an override effect here. In previous versions of Java, we were forced to add this annotation, which specifically marks the fact that we want to override that method from the base class. But now this is not longer required. So we can simply say the method definition and that's it. And let's also run this code to see this in action, right? So we should basically see here two prints, both coming from the dog class, right? And this is exactly what happens. Really important to note is to not confuse the override with overload. Those are two similar keywords which are very often confused by beginner Java developers, and they actually relate to two different things. So we just saw what overrides actually means, but let's see what overload refers. We say that a method is overloaded when it has the same name with another method, but it has a different set of parameters. So if we have a different method here, which is called walk, but this one takes a parameter, which let's say takes the number of meters, we say that the walk method is overloaded. So there is a duplicate method with the same name, but a different parameter set, right? So depending on how we call this method, or in other words, which parameters we pass here, right? Either none or a simple integer, the code will be executed on different paths, right? This is basically what an overloaded method actually means, right? It's just a different signature of a method with the exact same name. So that's the main idea between override and overload. Those are two really important topics that we should know. And of course, the inheritance topic is really important. Inheritance is basically a principle of the object-oriented programming, and you should really know what it actually refers to, specifically because it's used in a lot of libraries and frameworks. It's kind of a more advanced topic, but I really hope you got the main idea from this top level description of this particular principle. Now let's go on the next lecture.